Hello, here we are with another serial-to-serial communication video. In this case, it's going to be software serial-to-serial. I have an Uno here and a Mega here communicating using software serial ports. The limitation on the Uno is 4 software serial ports that I programmed here. I assume you might be able to use more, but I thought 4 was plenty just to show this demo. The Mega can have quite a few more software serial ports if you wish. So what I've done here is on the left side is the COM port for the Uno, and on the right side is the COM port for the Mega. And I've used both serial ports I have in the back of the laptop, COM5 and COM10, to communicate to the two devices so that we can see what's transpiring as data is being transferred back and forth. What this program does, actually it's 2 sets of programs, one slave program that runs on the Uno and one master program that kind of runs on the Mega. The Mega will generate the data and then send it over to the Uno. The Uno will process it and change it a little bit and then send it back to be redisplayed on the Mega. In addition to that, as data is being sent from the Mega to the Uno will analyze that numeric data and turn these LEDs on the breadboard on and off. The data I send from the Mega to the Uno is numeric and ASCII or characters or string, however you want to describe it. But I'm sending 2 different types of data. This project was difficult to get going. I had problems with serial communication, passing data strings back and forth, especially characters and stuff. That was difficult, but I think I got some clever ideas to show you. In addition to that, I will also show the schematic of this at the end, and I will show close-ups of the code for the slave or receiver Uno and for the master or sender Mega. So that being said, let's go ahead and dive into the code. So here is the code for the receiver, the Uno board. It says here that this is one half of this software serial-to-serial program. This is the Uno portion. It waits for the Mega board to generate and to send data to it. The data includes the following in this order. There's data, which is just a random number from 1 to 99 for generating data to transfer. The next port, random numeric number from 0 to 3 for each of the elements of the My Serial array. So there's 4 serial ports, and they're numbered from 0 to 3. On-off is the random numeric number 0 or 1 for turning LEDs on and off. And lastly, the board, which is a character string name of the active data generating board for generating characters to be transferred with numbers, and you can see above. So basically it's just the name of the board that's sending the data. To start the communication, I've always, after I've compiled the code for both of them, I open it and the COM ports are open and waiting. It'll sit there and wait, and you press reset on COM5, which is the Uno board first, and then you press reset on COM10, which is the Mega board, and then they start communicating. And initially there's a little bit of garbage that goes back and forth, and it all levels out. I wasn't able to start off with a real clean start for some reason. It was, even though I flushed the ports, and I'll show you about that, I just let it go ahead and kind of display a little bit of garbage initially. You may want to clean that up in the future. So coming down here, right here we have our receive, our RX pins, and these are the pins that the Uno can have. It can only have 4 that I know of, and these are the only 4 pins that can receive. So you couldn't use, say, 12 over here as an RX pin. Won't work. That port just won't work. Now the TX pins here, transmit pins, can be anything you want that's available. Again, I guess the point is the RX pins are the ones that dictate which pins are going to be ports. So one thing I had difficulty with coming down here now was setting up different serial ports. And I wanted to set it up as an array because I was originally going to put this in a function or a subroutine and then just pass the port number that I wanted to address. But I didn't wind up doing that. But this is a nice way to set up your serial ports. And so I've assigned SoftwareSerial, which is part of the SoftwareSerial library, and then I called it My Serial 1 through 4, and then I have initialized SoftwareSerial with the pins. That's part of the SoftwareSerial requirements. And so I did that for all 4, and then I set up an array here called My Serial with 4 elements, and they are called My Serial 1, 2, 3, and 4. And so that's the array of SoftwareSerial ports. Now coming down here, I set up, initialized the LED pins on the board and the LED pin on the breadboard. Just so you know, as the communication goes back and forth, as the data is transferred, the sending board will shut off the onboard pin 13 LED and turn on the receiving board LED pin 13. So you can kind of see the data transfer back and forth. And at the end of this explanation of all the code, I'll show this working again and it'll make more sense. So we come down here and I initialize the baud rate. I set up the variables. Test data is the actual string of incoming data that we transfer between the boards. So in the setup, I set up the baud rate for the COM port, USB COM port, and then I initialize all the baud rates for the ports that I've created between the 2 boards. I do that in a little for loop. I then set up the output for the pins, and I give a little delay because this stuff can happen so quickly that the communication between the 2 boards can get lost. So it's best to slow things down when doing this port-to-port communication, especially software. So in the loop, we have set up the current port, and this is why you pass the data this way. It's going to loop this huge for loop over and over and over as long as the current port is equal to 0 or less than or equal to 3, because My Serial's serial ports range from 0 through 3. And then I reset it down at the bottom. And this is just some debugging information. I have a function here called prime serial port, clear incoming serial port. And so let's go down to that. That will set up the serial port so that it's nice and clean. And that's right here. I basically pass it the port number. And what I do is I do a digital write to the RX pin, and I do a digital write to the TX pin, and I set those high. I'm not really too sure about it, but I did read on the web that this is a good idea, and it didn't seem to hurt it. And in fact, it seemed to help it clear out the port a little bit better. So you want really clean serial data ports, especially software, before you send or receive data. I call My Serial with the port number, listen, make it activate the serial port, get ready to hear or bring in some data, and then I flush it to make sure it's totally clean. And that's all this does. This is just cleaning the port to make sure it's ready to receive data. There's no weird characters or anything like that. So let's go back up to the top. And here we are back in. So that was my prime serial port. So that just primes it. And I do that on both boards. And in fact, something to note here, a lot of the code that I use in one, I also use in the other, because they're basically doing the same thing. So here the while statement, while the current port is less than 5, do nothing and just wait for the data string to arrive. This is really important, especially on the receiving. What you want to do on the receiving is wait first and always wait for data to come in. And then once data comes in, then act on it. And what I do here is I light the pin, the board, the Uno or the Mega, here in this case it's the Uno pin 13 high, so that it shows that I received the data. I wait a little bit. And then data is equal to the current serial port, software serial port, and I parse the I use the parse int command here, which pulls the first bit of data to the comma. This is all comma delimited data, and so that's the first portion will be just some raw data from 1 to 100. Next port will be after the comma. It'll ignore the comma and assign the next value, next port, because you need to know what port to communicate to next. And that's part of the data you need to send the receiving board. On-off is just rather to turn the LED on the breadboard on and off. Here we have the board. I zero it out, and then I basically look ahead to the end of the serial input buffer. I do a peek, which reads the characters one at a time until it sees a -1, and then I stop. And what I do is I put that in get character. In this case, it'll spell out the word Uno or Mega, and I read it until the very end, which would be a -1 of the input stream, and then it stops. If get character equals a comma, then what I do is I say board equals get character. What I'm doing here is I'm stripping out the comma. I don't want to have the comma included in the name of the board. And then I say got message from, and this is some debugging stuff, board. So it'll say the name Uno or Mega. Down here, I print out the incoming data string. I just do data, comma, next, comma, on, off, comma, board, comma. And then I wait a little bit for that to show up so that I know what data I actually received from the Mega to the Uno. Here I use a case statement. Depending on what the on-off value is, if it's a 0, if data is less than 50, because it ranges from 1 to 100 basically, or 0 to 99, then I turn the LED pin 2 on the breadboard high, else I turn it off. If it's a case 1, same thing. I turn LED pin 3 on, or I turn it off. And that's the end of the case statement. It's just so that the Uno can act on some data that it receives. Next, I take the existing data and I multiply it, because this is going to be the new value I send back to the Mega. And I just multiply everything by 10, and then I say the board's name is Uno. I then create the data string, the test data. Here I take the values that I generated up here and I put them into a data string. I wait a little bit to give it time to do all that. And then I say my serial current port, and I print that test data, which is actually going to shove it over to the Mega. From there, I then turn the LED pin on the motherboard, pin 13, off to show that I've sent the data and I'm done. So from there, that's the end of the for, that's the end of this loop. That's all the code you need for sending data to and receiving from the Mega on the Uno. So now let's take a look at what the Mega has to do. So now let's take a look at the code for the Mega. It's going to be very similar to the code for the Uno. Basically, this is the second half of the software serial. I set up the RX and TX ports here, just like the Uno. Here, 10, 50, 11, 51 are all required RX ports on the Mega. Now, the Mega has quite a few more. It maybe has a dozen or more RX ports that you can use. I only use these 4. The TX can be anything they want. So again, we set up our serial array, just like my serial array, just like I did in the Uno. And again, we have to include the software serial library. And this is how you label or access your own serial port using the software serial library. We have the same LED pin on the motherboard. I had a buzzer on this at one time. I don't use that anymore. Same baud rate is set up. Next port, same data. Everything's done the same. So now here in setup, we initialize the baud rate for the USB port serial monitor. We set up all the baud rates for all the software serial ports, the LED output pin. I create a random seed here to generate random data between 0 and 99. I delay a little bit. I have to tell what the current port is, because right away the Mega is going to be sending to the Uno first. So it has to have some sort of port number to start with. And I do prime the Uno, I believe, with a 0 also. So you do have to know a little bit of what port you're using initially. And then I prime the port using the same prime code, and I'll show you that down here, that I use in the Uno. I basically pass the port number, I set the RX and TX high, and then I also listen on the port because the Mega's sending first, and then I flush it out so that's nice and clean. So let's go back to, that's the end of the setup portion. In the loop portion, I put a breakout here, but that is not necessary. That was for debugging. So I was going to do some other interesting things with a go-to or something, command, but I decided not to. So that is not necessary. What is necessary is, again, we're doing a giant for loop from 0 to 3, less than 4. And our current port is 0. And this is for debugging here. The test data is cleared out, getting ready to be written new. And you also have to clear it out every time you go through each new port, because I cycle through different ports each and every time. I generate a data value here that's random from 0 to 100, not including 100, just goes from 0 to 99. I give it a little time to do that. Next port is equal to the current port. On off, I do a random number from 0 to 1, and then the board is the Mega. I take all that data, I create the string, just like I did in the Uno, along with commas. And so then we print the test data to the serial monitor so we can see what we generated. And then I also send that, this is the portion where I'm actually sending it to the Uno, where I do a print of the test data to my serial using the current port. I then turn the pin 13 motherboard LED off to show that I've already sent it. And then I clear out the port again, getting it ready to start receiving. And this is the key port right here, is this portion, is this while available statement. You do nothing and wait for the data string to arrive from the Uno. And so the way it works fundamentally is the receiver, the Uno, immediately goes into a wait state while the data is being created in the Mega. And then once the Mega has created it and sent it, it then goes in a wait state for the Uno to reply. And that's what we're doing here. So once we get the data, we write that the digital pin 13 is high, stating that we got the data, and we assign the variables using the parse int. It reads assign the data value read in up to the comma separator, automatically done by parse int, which was really a nice little feature. It'll read the data up to a comma, and then you can ignore the comma and get the data easily that way. The issue I had with character strings or a string was you had to reach each character at a time, and then once you got to a -1 at the end of the data string, you would stop. And if you got a comma, you would ignore it. And I found that it was easier to put the data string at the end of the message because it was easier to remove integers in the string and then process the characters at the end using the -1. That made it easy. So here we clear out the board. We peek ahead for a -1. We get the character. If the character's comma, we ignore it. And then we continue this loop until we get to a -1, ignoring the commas. And then that's finished. Board will equal the full string mega, or in this case, it would be Uno, because this is the mega. We print a little debug message, and then we print to the screen the values that we got. And then that's the end of the for, and that's the end of the loop. We start over with a new port that we generated up here. We generate, this is actually read in, I'm sorry, the port is generated, or next port is generated, this is current port. And from there, we generate new ports to use. So we cycle through the current port, which is generated right up here. And so that will cycle from 0 to 3. And that is linked to these right here. So serial 1, this is serial 1, 2, 3, 4. And that's how it cycles through. So that being said, this is all the code. Let's go ahead and go back to the functioning of the board and the monitor so you can see it a little bit more. So here we show, again, the two COM ports working together, communicating back and forth. I mention here showing which port I'm using. I also indicate which board is sending the message, and then here's the test string here. And then it sends it over to the Uno. This side's the Mega, this side's the Uno. And it says now processing port 3, got the message from Mega, here's the data. And then it sends back a value that is multiplied by 10, which is right there. It was 45, now it's 450, and it multiplies it by 10. That's what the Uno does. So let's take a look at the board here really quick. Currently, the Mega has the data, and then it just sent it to the Uno. The Uno has the data, sent it back to the Mega, back and forth, back and forth. And depending on what data the Uno gets, it turns these lights on or off, and which one, the yellow one or the red one, depending on the data, random data generated by the code. So this overall shows 4 software serial ports running between 2 boards with 2 serial ports open at the same time. Now, some of the tricks that you want to keep in mind, one, if you use, I would recommend using the parse int to read in integers or values, numeric values. Have characters and strings at the end of the data string if possible. The second thing I would suggest is separate data by commas, then read data string until -1. And if you read a comma, then ignore it. Another suggestion would be that you must have 2 while statements, one for the Uno and one for the Mega. This increases the timing so that, or not increases, but this allows timing. If you can, another suggestion would be to use the serial port like an array. You can send some characters and read some of them depending on what you want to do. But keep in mind that if you read 3 of the 7 characters in a string from the serial port, and then you do some stuff, if you read the serial string again, it'll be pointing at the 4th character. And that's why I clean out the serial port just prior to using it. It ensures a clean data line. One thing I do want to point out is I tried connecting a grounding wire from the Uno to the Mega, and I got some fluctuation in the LED, so there's some dirty lines that are going on. So there's no common power connecting the 2 boards together. I don't have the power sharing, though I guess you could drive all of this off of one port if you want it, off of one board if you wanted to. However, in order to see the serial port for both, I have to have USB for both. So I didn't connect the power. Also, something to keep in mind, in the code you will notice that the string declaration must be a capital S, not a small s. I made that mistake for a while. And lastly, the RX for the RX pins available for the Uno are 8 through 11, and the RX pins for the Mega are 10 through 13, 50 through 53, 62 through 69. And I know those are ones that are readily available. There may be more, but I'm not sure. Another issue I had was the communication between these 2 ports sometimes got stuck or locked up. And if they're not working for you, you might try adding a few delays to slow things down. That corrected my problem several times. I think that's just about it. Other than that, I found that this was a pretty difficult little experiment, but with this information that I've provided you, it should be a lot easier for you to do even more with the serial port, software serial ports on your Uno. I will show the wiring schematic at the end of the video here so that you can duplicate the wiring that I have. And if unfortunately I don't have any way for you to send me email to respond, I also don't have a website, so that's why I'm showing the code slowly so you can write it down or copy it off the screen. Please comment or subscribe or share with anyone you wish. I hope you find this video informative. I will be doing another serial communication video, I2C, shortly, and that'll be the end of the trilogy of serial communication. I've done the hardware one, I've done the software, now I'm going to do the I2C. So if you enjoy, please leave a comment. Otherwise, good luck, and thanks for watching.